I will now work through Skew Lines 2, our second worksheet on skew lines. Now I would recommend, just as a quick recap for yourselves as well, to have a quick look over your worksheet 1, or alternatively look quickly back over the previous video on skew lines. Now what we have here, so the direction of two parachute jumpers landing are represented by two skew lines A, B and C, D. So if you imagine one parachutist jumps out of the plane at point B, lands on the ground at A, the second lad jumps out at D and lands on the ground at point C. Now, skew lines, to quickly go back over, are non-intersecting lines, and they're also not parallel to each other. So for example, my two pencils there, okay, they will never intersect each other if I extended them out, and they're also not parallel to each other. So that will be an example of two skew lines there in front of us. Now what we need to do, so our key principle that we focused on the other day, a plane is drawn containing one of the lines, so one of the skew lines, and having a line on it parallel to the other skew line. So I am going to create a plane that contains the line CD, and one of the edges of the plane is parallel to AB. So I'm going to begin with that now. So I draw a line parallel to AB from point C, and if you remember from the other day as well, parallel lines are parallel in every view. And then I'm just going to bring my horizontal line across from point D, and that is going to give me my plane CDP, my triangular plane there, like so. That's my plane. I now need to draw that in the plan. To draw that in the plan, I need to find where point P is. So I'm going to drop down point P to the plan. The line CP is parallel to AB. Therefore, it has to be parallel to AB in the plan. Now AB here is actually just parallel to the XY line. So parallel there to AB from C straight across. And that there then is point P, and I will join P to D, and there is my plane that I have now created. Now, because the line DP is horizontal in the elevation, it is a true length in plan, because we are looking 90 degrees to the line in the elevation to generate our plan view. So that is a true length line. Step 2, very same as what we covered in our previous worksheet. We want to now view this plane as an edge, and we want to see if it is parallel to the skew line AB. So what we are going to do is project an auxiliary view looking along that true length line. And I'll project all my points A, B, C, D and P. And I'll put in my X1, Y1 there. And then I will count back my two views to take my height, so I will be taking my heights from the elevation. Now straight away I can see there A and C are on the XY line, so I can go and mark A1 and C1, and I'm just going to drop a light vertical line down and take the height from either B or D, doesn't matter. Now, at this stage you will also notice point P would be directly behind point D. So I'm just going to quickly label those. And I will now draw my skew line AB, my auxiliary view, and my triangular plane which I created now appears as just a line. So I know I'm on the right track. These should always appear to be parallel in your first auxiliary view. Now, the new part, so that's all what we covered in the previous worksheet. So the next part now is new. Determine the shortest distance between the skew lines and determine the projections of this shortest distance. Now, what they are looking for, so if I take my two pencils there again, they are looking for the shortest distance that I could measure, okay, between those two pens, so it would be a distance in here somewhere. Okay, now to actually work this out accurately on our drawing page, we are going to project a second auxiliary view. So the shortest distance, we're going to project a view looking perpendicular to our skew lines. So a second auxiliary view looking 90 degrees. So I'll project my points off to the left. And I will put in my x2, y2. Now what I am also going to do at this stage, remember we count back our two views for our distances. So 1, 2 views back we will be measuring from the plan. So what I'm going to go and put in is a datum line parallel to my x1, y1, like so. And it is just purely coincidence there that passes through A and D. Usually it will only pass through 1 point. So from my datum line then I'll measure my distance to B, step it off from my x2, y2. I will label that there as B2. We don't need to worry about point P anymore. So I'll get point C there now. So you don't need to take a distance there for P. And then A and D are on the datum line. So they will then both be on my x2, y2. And then all I'm going to do, join A and B and C and D. And the two skew lines will appear to cross over now, or intersect, but they're only appearing to intersect because we know skew lines never intersect. Now, if you imagine, there's my two skew lines again. We have now projected a view where they cross over, or appear to cross over like that. Now, this point, where they appear to cross over, is how we're going to find the shortest distance now next. So what we will do is where they appear to cross over, we will project it back to the first auxiliary view. And there is the shortest distance, that line there. Now, part B of the question says determine the projections of the shortest distance. We need to draw this line in our plan and elevation. So I'm going to call this line, line 1, 2. So point 1 is on the line CD, point 2 is on the line AB. And then all I'm going to do is project those 2 points back through the views. So point 2 is on the line AB, point 1 is on the line CD. And I will label there 1, 2, and I will draw that line in. And then I will bring them straight up my elevation. Now if we think of that shortest distance back in the context of our two parachutists, if you imagine as those parachutists are falling through the air or descending, that pink line is the closest that they will get to each other as they are falling. And that is how we find the shortest distance between two skew lines.